Okay, hello everyone. My name is Dominico Felix, and I'm from Team TM-81, and in this video, I'm gonna explain our model on analyzing the CTG data. Okay, so first we are gonna import all the library that we are gonna use and import the file that we are using right now. Okay, next is cleaning up the data. We are gonna remove the column that we are not gonna use, such as the NaN column and the last three row of the data sheet. Okay, the next step is actually analyzing the data by plotting them into the histogram and a heat map graph. So based on the chart, we can actually analyze some of the uniqueness of the each feature and also analyze the some useless features such as the DS and DR where they doesn't show that much distribution. Then we think that it might actually confuse the data during the training process. So next in the video, we are gonna see the performance of the data with the selected feature and the unselected feature. Okay, next we notice that the NSP1 is takes the majority part of the data, where NSP2 and 3 is actually very few compared to NSP1. So we are gonna resample NSP2 and NSP3 so that they balance out. Next, we plot the graph again with the balance data. Okay, the next part is actually preparing the data for the training process of the model. So first we are gonna resample them and then we are gonna scale them so that the value doesn't differs that much and could potentially confuse the model during training process. Okay, we also gonna split the data into 70% training and 30% testing. Okay, we also try to make the data using the selected features. So we select some features that we are not gonna use and they are the S and the R and N zeros and some new features that we make such as the LB category feature that we make because it is weird where the LB category where it is considered high and low turns out to be NSP1 outcome, where the NSP2 and NSP3 takes the normal LB category. And we also plot the MSTV and MLTV where we think that this feature actually gives much clue. And then we also find the T-square of the data of the feature and the p-value and decide whether they give significant impact during the training process or not. And we see that the three part actually gives small impact to the training process. And we also plot the heat map correlation to see their correlation such as the UC1 and AC where they are highly correlated. Last is actually making the prediction model. So we try several model with the selected feature and the unselected feature. So first is the KNN, where the unselected feature actually perform better with 89% accuracy and 6 false negative, around 1.4%. It's pretty good. While the selected feature actually perform much worse with 1.5% false negative. Next is the log regression, where again the unselected feature perform better with 88% accuracy and very low false negative around 0.7%. And there's support vector machine with 90% accuracy and 0.9% false negative. And then random forest where this is very bad because the false negative is very high, around 3.5%. And then the model that we are gonna use is actually neural nets because this model is very good. So in the neural nets part, we actually try to find the best of weight configuration of num nodes, dropout probability, learning rate, and batch size. And then using that weight, we can use it to analyze our data And turns out it actually performed really well with 91% accuracy and very low false negative, around 0.7%. Besides that, the neural nets model can be adjusted really easily with their weights values, and can be easily adjusted based on the condition uh, at that time. All right, thank you for listening to the video. Hope you understand. Thank you so much.